Our lesson on 2.1 covers functions and their graphs. And we're going to begin with a little bit of vocabulary. So our first vocabulary term is a relation. And a relation is simply a set of ordered pairs. Now the domain of a function, or the domain of a relation even, are just the x values for which the function exists. So you can just think of domain as being all the x values. The range are all the y values for which the function exists. And then a function is a relation where every x only has one corresponding y. So it's a set of points, which is a relation, where each x has only one corresponding y. So every x can only be paired up with one y term. So let's look at the first two examples. We're going to identify the domain and the range and then tell whether or not these relations are functions. So they call these inputs and outputs, but you need to realize that the input is really just the x variable and the output is the y variable. So the first question is the domain, and we're just going to list out all the x values. And since there's only 3 in this relation, we're going to say -3, 1, and 4. And it doesn't matter how you list them out, what order, but we usually go least to greatest. So for range, if I list out all my y values, and again, order does not matter, but I always try to go least to greatest, -2, 1, 3, and 4. And then to determine whether or not this is a function, remember the definition of a function was every x can only have one corresponding y value. And if I look at my x's and who they're paired with, I see that this guy right here, x number 1, is being paired with a -2 and he's being paired with a 1. So this relation is not a function, and simply because that one x value is paired with more than one y value. When I look at example number 2, the domain of example number 2 is -3, 1, 3, and 4. I'm using set brackets, not using parentheses or normal brackets. These are set brackets. The range of this relation in any order, I'm going to go -2, 1, and 3. And then if I look at all my pairings, this x is paired with that y, this x is paired with that y, this x is paired with that y, and this x is paired with that y. So this is a function, and I notice that there is something kind of strange going on. Right here, y of 1 seems to be paired with two different x's, but remember the definition of a function is that every x can only be paired with one y. It never mentions any restrictions on whether any y's can be paired with more than one x. So that's why that one is a function. There's another way to determine whether something is a function, and that would be using the vertical line test. So if a function passes the vertical line test, we say, or if a relation passes the vertical line test, it is a function. So let's draw a few examples. I'm just going to jot down first a standard parabola. And the way the vertical line test works is if you're going to draw a whole bunch of pretend that's vertical, vertical lines in this relation, each vertical line can only touch the function once if this is a function. So this relation passes the vertical line test, so yes, it is a function. Let's look at another example. Forgive my drawings, they're not very pretty. Okay, a little sideways parabola. If you notice, I can draw on a couple of different vertical lines where one or more of these vertical lines is going to touch the relation more than once. So since this happens, this guy actually fails the vertical line test, and that's why it is not a function. it still goes along with every x can only have one y. A vertical line would be an x value, and if it touches twice or more than that, that particular x value has more than one y value, and that's why it is not a function. So let's look at our next example. Find the domain and range from each graph, and are they functions? Now this is going to be a little different from what we did with the set notation. These functions, or possible functions, have interval domains and ranges because they hit every single value between an interval. So when I look at domain, remember domain are x's. So I try to think about where this guy starts on the left and where he ends on the right. And it looks like he travels from -6 to 6. So we write this as -6, 6. And then to signify that it hits everybody in between -6 and 6, but also the endpoints of -6 and 6, we use brackets around them. Now for range is y, and we always read bottom to top. So least to greatest would be -3 up to 4. And again, since it does hit both of those values, we're going to use brackets around it. And then, is this a function? We're going to try to figure out if this guy passes the vertical line test. So I'm going to kind of think about drawing a whole bunch of vertical lines in. Each vertical line only touches the function once, so it passes the vertical line test. And is it a function? Yes, it is. So let's look at the domain for number 2. The domain goes from left to right. Let's see. So we have -7 to 6, and since it does hit -7 and 6, we use brackets. For the range, I look at how low to how high this possible function travels, and he goes from a -1 up to an 8, and again brackets. And does this pass the vertical line test? Well, yep, each vertical line will only touch once, so yes, this is a function. Okay, number 3, the domain stretches from here to here. Now, it was not my intention to make these come out as kind of decimals, but if you look really closely, the leftmost x value there looks around -4.5. On a quiz or a test, I'll make it a little more obvious. If you said that was -4.6 or -4.4, I wouldn't care. It's not, you don't have to be that accurate. Now, to the right, it looks like it ends at a 7, and it does hit both those values. It lands on them, so we're going to put brackets. Now for the range, that's low to high, so let's just call that -2 to 2, and again, brackets. And this time, I ask whether it passes the vertical line test, and it sure does not. Any one of these lines hits twice. So since this fails the vertical line test, no, it is not a function. Okay, number 4. Now be careful. On number 4, there are arrows on the ends of this graph indicating that it goes forever in those directions. So domain, if I think about how far to the left and how far to the right it travels, it actually goes forever. So what we call that is -infinity to infinity. Now here's the trick. You can't actually land on infinity. So since we can't land on infinity, it doesn't exist technically, we can't put brackets, we're going to put parentheses around these. Always parentheses on infinity. Now for range, that's how low to how high. Now it definitely has a bottom point for a y value at 0. But then it goes up forever, so it goes up to infinity. Now be careful. It lands on 0, so he has a bracket, but again, we can never land on infinity, so he has to have a parenthesis. So sometimes in an interval, you'll have one endpoint that's a bracket and one endpoint that's a parenthesis. And then does this pass the vertical line test? So I draw a couple of vertical lines in, and yes it does, so it is a function. Okay, same idea here on number 5. The domain goes forever to the left and forever to the right, so we'll say -infinity to infinity. The range, let's see, it goes how low? It would be a -3 up to infinity. Actually lands on -3, so we put a bracket. Can't land on infinity, so it's a parenthesis. And yes, it does pass the vertical line test, so it is a function. Now on number 6, again, I didn't intend this to be that goofy, but here's our leftmost endpoint. Let's say that's at -4.5. Again, if you're not going to say exactly that, that's fine. And then to the right, it seems to travel forever, so we're going to call that infinity. Now it actually lands on -4.5, to infinity. And then for range, how low is it? Let's see. Looks like -3, and then it goes up forever to infinity. It has a bracket on -3, but a parenthesis on infinity. And then does this pass the vertical line test? Sure does. So yes, it is a function. Okay, now 7, I really did not intend this to be this difficult, so I apologize. The domain of number 7, if you kind of look at the leftmost endpoint, it seems to be at, -6.5 maybe. And then it goes forever to the right. So we're going to have a bracket on -6.5, but a parenthesis on the infinity. Now for the range, you have to look at the lowest point, which would be actually down here. So, I don't know, maybe -6.75? Again, it's really hard to tell, so as long as you're in the ballpark. And then it goes up forever, so that goes up to infinity. So a bracket on -6.75, a parenthesis on the infinity. Now this is the part that I did not intend this to be this difficult. When you start to draw vertical lines in, it seems to be okay until you get to like right here. The function or the relation seems to kind of backtrack a little bit. So I'm thinking it actually fails the vertical line test right over here, the way it's drawn. So I'm going to say no, this is not a function, because I'm going to say it fails the vertical line test right here. However, I will never give you something that sneaky. It'll be far more obvious on a test or a quiz or on your homework. Okay, and then number 8, the domain from the left to the right. So it goes forever to the left, so that would be -infinity. And then if you look at how far it travels to the right, it looks like it goes up to 4. And it actually lands on 4, so a bracket. And if you didn't think it was 4, you thought it was 3.75, that's fine. The range, how low to how high, well, it goes forever down and forever up. So that's -infinity to infinity. And then does this pass the vertical line test? Is this a function? No, it does not. So it's not a function. That concludes the lesson on 2.1.